Hey, what's up, Nerdgasm fans? Jerry here, aka Barnacules. Now, you guys know I'm a software developer. I've actually developed software for Microsoft for 15 years. Well, needless to say, I'm no longer with Microsoft. If you'd like to know more about that, there's a video down in the description. But at this time in my life, I'm gonna be my own boss now and focus on my passions, and that's programming and making videos for you guys.
YouTube!
Well, I get a lot of questions from you guys asking what it takes to become a developer, what language you could use, how long does it take, what school do you have to go to, do you have to drive a certain car, whose butt do you have to kiss? I get a lot of questions. So I decided instead of responding to literally hundreds of emails, which could take a lot of time, the faster route would be just to create a whole new video series to just show you guys how to do it. So I introduce Codegasm. In this new series, what I'm hoping to do is show you guys how to get up and running quick and learn your first language. So we're not gonna be focusing on super technical things. We're not gonna get into deep theory of processor architecture, memory management, polymorphism, multiple inheritance. We're not gonna talk about that, okay? That's the last you're gonna hear of it.
Well, I don't know, you might hear of it once or twice more.
But what I'm gonna focus on in this series is quick little modules to get you guys interested, get you up and running, and kind of learn how programming works. This is gonna be a very, very basic series. So if you already know how to program, especially in C#.net, hey, you may wanna watch the video just for some lols, and you're welcome to do it. So guys, sit tight. In this first episode, I'm gonna show you how to set up your development environment. For this series, we're gonna be using Visual Studio 2013 Express. Express means you don't have to pay for it. We'll get into that here in a minute. Because free is good, especially when you don't have a job.
Too soon. Too soon.
Hey, what's up guys? Okay, so this is the format that we're gonna use for this series of videos. I'm basically screen capturing a VM that I have set up that has Windows 8.1 on it, and I'm gonna walk you through the steps of setting up your first development environment. So the very first thing that you're gonna wanna do is go to this link, and it's down in the description. You can just click on it, and this is actually gonna be where you go to get Visual Studio Express. I'm gonna actually open up my Chrome here, and we'll navigate out. All right, once you're to this page, you're gonna wanna scroll down. Don't get the web version. Don't get for Windows. This is a little confusing because this is for writing modern applications. We want the desktop version right here. So go ahead and click download. And if you want a language pack, you can select that over here. Or you can download the installer that'll install from the web by clicking install now. Or like I did, you can just download the ISO and then you have it so that you can install it on as many machines as you want. All right, so you can see I have the ISO sitting on my desktop. Well, if you have Windows 8.1, you can just double click the ISO to mount it. All right, so now we have the ISO open as a folder, so we're gonna go ahead and just install it by double clicking the application here. Now, I'm just gonna install it to the default location here. So let's go ahead and agree to the terms, and you can also join the Visual Studio Experience program, which will send crashes and information to Microsoft to help them improve the product. Okay, let's go ahead and install. Now, of course, you're gonna get the UAC dialog if you have security configured for it by default, so let's go ahead and click yes. That's just an extra precaution. If you ever wondered why those boxes popped up, it's just to make sure that you know that something's trying to do an administrative task on the computer. And this is good because then if you run something malicious, you have that one last chance to stop it and be like, no, I didn't run that, hit cancel. All right, so let me give you guys a little bit of background on programming here. Hopefully you're completely new to it because I'm assuming that you don't know anything about programming and you haven't done anything before. Doesn't mean you couldn't learn a couple things if you already know how to code, so hang in there, but we're gonna start with the basics. Now, Visual Studio is your dev environment, like I was saying. It's basically your really hopped up text editor for writing your code. And when I say code, what I'm talking about is you actually write a kind of human readable language. We're gonna use something called C#, and the language determines the syntax, basically how you tell the computer what to do. But then there's another element that's built into Visual Studio called a compiler. And what a compiler does is it takes that human readable text and converts it into machine language. Now, the language we're going to be using for this tutorial is C#.net. Now, they're actually different entities. C# is the language and .net is the libraries that the language uses to manipulate things on the computer. Now, so you guys know what I mean when I say library. Just think of a library. A library contains a ton of books. Well, a library in programming contains a whole lot of knowledge on how to do activities. So if you want to do a certain thing, you go get a certain book from the library to learn it. Well, same thing in computers. You want to do a certain thing, you go get a specific library and it contains that functionality and knowledge to carry out that task. All right, hopefully I didn't lose you guys with all that. So the whole idea with this editor is you go in, you create your program, and you basically build on operations. It's just like tools. If you wanted to make a hammer, right? You would go and forge the head of the hammer, and then you would go create the handle for the hammer, and then you'd bring those two together, and then you'd have a hammer, and then you could use that hammer to build something, and then you could use that something that you built to build something even bigger. Programming is like that. You start with small elements and you keep building on them until you get a big element. All right, once this is done installing, I'm gonna go ahead and show you guys some of the features, show you around Visual Studio a little bit, and then we're gonna go ahead and jump right into it and create our first program. All right, well, we now have Visual Studio 2013 installed successfully. So we can just go ahead and click the launch button here. Once you get through the initial dialog starting it for the first time and you select your preferences, you end up at this screen right here. This is like the main hub when you start Visual Studio. Now, I want to urge you guys to do some exploring. If you look over here in these panes, there's tons of links to talking about how to create things. Some of these are high-level topics, some of them are low-level topics, but there's a lot of information to be found starting from this point right here. Now, we're going to be developing in C#, but this is a capable program. You can do Visual Basic, you can do C++, you can do WPF, Windows Form, web development, you name it, you can do it. So what we're going to do to get started is we're going to create a new project. Over here under Start, just click New Project. Now you have lots of options right here. What we want to do is go down to Visual C#, because everything that I do in this video series, at least for now, is going to be in C#.net. So we're going to say we want to create a Windows application. Now you notice there's multiple different templates. All these templates are is different project types that start out with the foundation already built for you. That way you don't have to start from dead scratch every time you create an application. Now the easiest type of application to create is a console application. Now a console application is just a text-based application that runs from the command console. We'll go ahead and just give the application a name down here. We're going to go ahead and call it Test App 1 Codegasm. Just like so. We'll go ahead and just leave it in the default folder. Now down here there's some checkboxes. There's one that says create directory for solution. I like to leave that unchecked because then it puts everything in one directory. If you leave that checked, it puts the solution, which is like the main template file that brings everything together, one directory up, and then it creates another subdirectory that contains everything else. All right, we're gonna go ahead and click OK. Visual Studio is now creating my test app project. Now, before we go any further, I just want to demonstrate for people that don't know what a console application is. A console application is when you open up CMD.exe, also known as the command console. It's this window right here. And it's basically DOS, for lack of a better explanation. It pretty much is. I mean, it's just basically your little sub-operating system from a command prompt. You can start things from here. You can open things like Notepad. If you want, you can do things like look at the files, see, you can look at all the files and all the directories. I mean, there's a whole bunch of commands. If you type help, you can get a list of most of the commands that you can run from the command prompt. Basically, this is just a place where you run console applications. All right, so now that's established, let's go back to our program. Now, the file that it opened, if you look over here in the little solution folder over here on the right, you can see there's a program.cs file. That's our source code file. That's where all the code is going to go for our program. Now, you can create as many files as you want. You can link those files together. You can do all kinds of really advanced things, but because I want to get you guys jumped in really quick and get you interested, we're going to ignore all that for now. The only thing that matters is program.cs. All right, so here we're inside of program.cs. You can see up above we have some using statements. We have something called a namespace. We have something called a class, and we have something called a function. So we're gonna go ahead and just put some comments on these guys. This is a namespace. This right here is a class, and you wanna heavily comment your code. You can see right here, I'm just using ///. That's basically the signature that tells the compiler, ignore this, it's just a comment. And then you have the function. Now this function right here, they otherwise known as an entry point. I'll go ahead and just put that right here. This is basically where your program starts. When you run your program from the command line, when you type the name of your program and it runs, this is where it starts. This is the starting point of everything. Now, one quick thing to note is up here you see all these like little using texts. What using means is that basically these are namespaces. Each one of these little guys are namespaces. And a namespace is this thing right here. Basically what this is doing is creating a namespace called test_app_1___Codegasm. I know it's not very pretty, but you can call it whatever you want. We'll call it Jerry's Cool App Code. That's my namespace. Now everything between this opening bracket and that closing bracket belongs to that namespace. It's just a way of grouping things together basically. Similar with a class contains functionality. So the class contains functions and variables, things that you want to run to actually evoke a certain response out of the computer. And then you can see this class right here. This is called a scope, by the way. Between this guy and this guy, everything belongs to that class. So basically, if I select all this, that's all in the class. So the class program contains a function called main. That's what you would say if you were talking all programmatically. But at the end of the day, for this example, all we care about is main. Main is important. So now the first thing that I want to do in our little program here, this little demonstration, is I want to basically print something to the screen. I want to show the user something. So to do that, you just type console. Now console is a class which contains functionality. So if I just push period, you can see I get this thing called IntelliSense. It pops up and it shows me all of the properties and all of the functions, basically everything that's publicly available for me to use under that class. In this particular case, we want to call a function called writeLine. And if you want to put text inside of this, you basically have to put everything in quotes. Anything you put in quotes is just a literal string as far as it's concerned. So if you don't want to create storage for that, like for instance, I could do something like this. I could come up here and say, I want to create a string object. An object is just another fancy name for class or structure, depending on what you're doing. Let's say I want to create a string. I can say string, Jerry string equals, hello, this is Jerry's string, for example. Now, I can take this variable right here, and they call it a variable because obviously it's variable. You can put anything you want into it that's its type. Like, for instance, I can only put strings in a string. Just like if I created a number, otherwise known as an integer, I can only put a number in it, no quotes around it. Now you notice at the end of each line, I'm actually putting this little semicolon. And the semicolon basically just tells the compiler that, okay, I'm done with that operation. That's one complete operation. So now down here, if I want to write that string to the console so that the user can see it, I can type in Jerry string, just like that, and then I end it again with the semicolon. And if I just run this application, which you can hold Control and press F5 to do, or you can just come up here to debug, and you can go to start without debugging. And I'll explain debugging and without debugging later. So start without debugging. Now it's compiling my application. You can see down in the output below, and it pops up and it says, hello, this is Jerry's string. And then we just push a key and it just kills the application. Now I can also come in here and just put whatever I want in here. This is Jerry just typing random stuff to the screen through console writeLine. Like that. Now, if I do that and I run the application again, I'll just hit Control F5. That's the shortcut. You see it pops up and it shows that string. Now, the cool thing about using variables is it allows you to keep all of your fixed data at the top, all of your constant data at the top of the function, so it's very, very easy to manipulate and tune as you go. It's generally frowned upon to just put strings into functions like this right here. But again, this isn't a professional tutorial. I want to get you guys interested in programming, so we're just going to do it the fastest way possible. All right, so I've cleared out the main function. Now we're going to do something a little more complicated. Now we want to print something to the user, and we want to get the user to respond back to that and then do something with it. So for this demo, we're just going to do a console writeLine just like we did before, and this time I'm going to say type a number, any number, just like that. Now what we need to do is we need to get something back from the user. So what we do is a console.read key. This will read a single key from the keyboard. Basically, it'll block your program, meaning it'll stop execution of your program until a key is pressed on the keyboard. Now, the thing is, we need to store that key somewhere because we want to do something with it. So one cool thing about Visual Studio is you can literally just hover your mouse over things. You can see right here, and it gives you information on like what the functions take as input and what they return, meaning what you get back from that function when it finishes executing. So in this case, the read key function returns a console. If you look, it returns a console key info object. So we want to create one of those. We want to say console key info, and we'll just call it key info. So the first thing that you type here is what you're trying to create, and then here is your friendly name that you want for that instance that you created, because you might want to create multiple instances. If you wanted another one, you could do a console key info 2, for instance, and then you would have two separate key info objects. So these are the names. So anytime that you define something, like you want to define a variable, you first say what variable type you want, then the name you want to give to that variable so you can recall it and use it later on, and then what you want to put into that variable, which, like for instance, I could just create a key and feed it into it, but in this case I want to get it from the console, and that's why I call rekey. So now what that is going to do is read the key into key info. So now this little key info guy right here, after I press a key, is going to contain the key that I pressed. So now I can do console.writeLine, did you type, and then use these little parentheses here, and 0. This means I want to basically put something, I want to take a variable and replace that with it. And then I put a little comma right here, and then after it, now it wants what I want to replace that with. So for instance, I'm going to do key info, which is what we just gathered before, And you can see under key info, there's a couple sub parameters that you can select, otherwise known as properties. And you can select the key, you can select the character that the key produced, modifiers, all this stuff. All we want is the key character. And then we want to do toString. And that'll basically convert it to a string that will replace this right here. Now, there's a lot of complexity behind what I'm doing here, and there's a lot of variation you can do. That's what programming is all about. You pretty much have infinite variability. But I'm trying to show you guys how to do something very, very quickly. So now if I compile this program and hit Control F5 to run it, you're going to see it says type a number, any number. So I'm going to type the number 5. And you see, it says, did you type 5? It's because it took that number, it stored it, and then it gave me a string back and replaced that to show me the number that I typed. Now, that's a very, very simple program, but what I've shown you so far is how to easily write something to the screen, how to get something back, and then how to use that. Now let's take it to a little bit more of a complex program. Now we want to add some logic, and logic is basically just direction of the program. Based on certain inputs, it's going to make certain decisions. So now let's do something conditionally based on what I typed. Let's say if, you can do this little thing, if the key info character is equal to a lowercase a, then I'm going to create this. And remember, this is the scope. So anytime that you do logic, you can do ifs, you can do fors, you can do whiles. You can look these things up if you want. These conditional situations, basically, if this is met, if this is equal to a, then it's going to run the code between these 2 points. Otherwise, it's just going to jump over it and keep going. So I'm going to say, if the key character that I type is A, which you know isn't a number, just for example, it's not a number, that's what we're doing here, then I'm going to do a console write line, and I'm going to say, that is not a number. Knock it off now. Just like that. Now what's going to happen, oh, sorry, and I commented this code out earlier, but just to let you know, anytime you don't want a piece of code to run, but you still want to leave it in the program because you may want to bring it back later, just use two forward slashes. All right, so now what's going to happen if we run this program? Hit Control F5. It asks for a number. I'm going to give it a number. It says, did you type 3? Okay, that worked. Now what's going to happen if I press A? That's not a number. Knock it off now. But then it says, did you type an A? Okay, so what happened here is when you type A, it ran this code, and then it came down here and ran that code. It basically is top to bottom order, and then it skips the logic that doesn't match and goes through the logic that does. Hope this is making sense to you guys. I don't do a whole lot of teaching, but that's one of the reasons why I wanted to try this series out, is I think it would be fun to basically walk you through stuff from the absolute ground up. I don't see a lot of tutorials doing that. A lot of them assume that you have a lot of basic programming experience. Now, don't be overwhelmed if you don't understand everything that's going on right now. Just play around with it. I urge you. You will learn a lot through trial and error. Okay, so now what we're going to do is on this condition here, this little if block here, where I say if it equals A. Well, if it equals A, I don't want it to run that block of code. So I have a couple of options. I can do something called an else. Else is just what it is. Do something, else do something else. So, man, that's a lot of else's. All right, so what we're going to do here now is if A is pressed, it's going to run this code. Else, if A isn't pressed and it's any other character, it's going to put that line of code. So if we run this program again, and you see I type a number, it says, oh, did you type 4? Perfect. Okay, now what happens if I type A? That's not a number, knock it off now. Notice it did not print did you type. This thing right here, it skipped it. Now this is fundamentally how programming works. It's just very, very large blocks of simple code. The way that programming works in general is that you have the machine language, and then you have a layer of abstraction from that, and then you have another layer of abstraction from that, and it basically keeps getting simpler and simpler, and each one of those layers groups together a bunch of constructs from the layer beneath it. Like, let me give you an example that was probably wickedly overwhelming. Let's just say, go back to the hammer analogy, right? The lowest level part of programming would be the metal that the hammer's made out of and the wood that the handle's made out of. The next level would be the hammerhead itself forged and the handle itself. The next level would be combining those two things into a hammer. Well, it's easier to just pick up a hammer and use it to do stuff than having to learn how to smelt the metal and build the hammer and then use the hammer. A language like C# has libraries, which I was telling you about a little bit earlier, that are inside of these namespaces, and these libraries contain those functionalities. One of those may contain the hammer, so I can use the hammer. I don't have to go build the hammer before I use it. Now, to give you a little bit of a better example, you can create stuff called functions. Everything is a function. basically in programming. You create a function. The whole concept of a function is you run a function, you give it variables, it does something, and then it returns a result. That's how functions work. So we're going to create a quick function here. And we'll just call this function print foo to screen. That's all this thing's going to do. And inside of it, I'm going to do console.writeLine foo. Just like that. And let's put a little comment on it too. If you do 3 slashes at the top of a function, it actually gives you this cool little template that you can type into. It's pretty awesome. You should use it. So now we're just going to type here what the function does. All this function does is print foo to the screen. That's it. That's all this function does. Now that I've created this function, I can come up here and just use it anywhere I want. To use it, all I type is the name of the function. That's it. Now I can run this. I'm going to press a key. Oh, you see it printed foo right there. Because what happened in the program? Again, top to bottom. It asked for a number. I entered a number. It printed foo to screen, because this function basically says go run everything between this point and this point. Functions are just a really good way of organizing and structuring your code. Now to build on it, like I was telling you earlier, let's create another function. Let's create a function called print foo to screen 100 times. All right, so now inside of our print foo to screen 100 times, we basically want to create something called a loop. And what a loop is it basically tells the program that I want to run a certain piece of code over and over and over again until a certain condition is met. Now, since we want to actually loop 100 times because we want to print foo to the screen 100 times, we're going to actually use something called a for loop. Now, the way the for loop works is you type for, and then it takes 3 inputs. The first one is the counter. Basically, this is going to be literally a counter that each time through the loop we're going to increment. So I'm going to go ahead and create an integer called counter, and I'm going to make it equal to 0. The next is the condition that has to be met for the loop to continue. As soon as this condition is no longer met, you break out of the loop. It stops running. So for this case, we want to say the counter is less than or equal to 100. So as long as counter is the number of counter is less than or equal to 100, I want to keep running that code. And then the next thing is how much I want to increment counter. So each time through the loop, we want to increment counter by 1. So I'm going to increment counter by putting 2 pluses after it. That means increment it by 1. Now, for argument's sake, if you wanted to increment it more than 1, you'd use this syntax. You'd say, I want to set counter equal to itself plus 2, for instance. And then that would increment counter by 2 each time through the loop. But for this example, we're going with plus plus. Okay, so now we're inside of the loop. Now, we could do a console write line foo, but we already have a function that does that. We created a function called print foo to screen. So we're going to go ahead and call print foo to screen, just like that. So now, if I run this program, what's going to happen is you're going to come down here, it's going to print type number of any number, you're going to press a key, then it's going to run a function called print foo to screen 100 times, which basically is going to jump all the way down here and run this code. And then each time through the loop, it's going to call our other function that prints just 1 foo to the screen, which then will jump up here and run this code. And so these are all these order of operations that are occurring, and they also call it a stack, because in programming what you do is one function calls another function, calls another function, calls another function, and that's how you get that rich functionality at the very, very top without having to know how to do each and every little thing on the computer. A good example of this would be console write line. If you look up here, I'm saying console write line and I give it a string and it prints to the console. What you don't see is behind the scenes, there are tons of functions being called inside of that function to set focus to the console, set the font, print to the console, create a new line. All that stuff is being done by other functions, but you don't need to know about that. You just want to print a line of text, so you call the higher level function write line. It's just like the hammer analogy earlier. You don't need to know how to smelt the metal. You don't even want to know how to build the hammer. You just want to use the hammer. And that's what these high level functions allow you to do in the .NET framework. All right, so what's going to happen if we run this program right now? Control F5. I'm going to press a key. Foo just printed 100 times. And that's because we created that function. Now let's say I want the program to start and I want that to happen immediately before anything else. I can take that, cut it, put it at the very top of the program. All I did was move this function. And now when I run it, what's going to happen? It's going to print foo first before asking me what number I want, because it's that top down. Everything's from the top down. All right, so for this very first video, I'm trying to keep it as simple as possible. Hopefully I didn't go over anybody's head. If I did, feel free to send me questions over at Twitter. I'm at Barnacules. I'll try to answer as many as I can. And I do urge you to go out and do research and look for stuff. I have a ton of links down in the video description to things like MSDN and libraries and Pluralsight and places where you can actually go to continue the education. The goal of this video series is just to kind of give you that kickstart and show you the early capabilities and how easy it is to get started so that then you can go and build on that. So now we have our program built here, right? It's an interesting program. It prints foo a whole bunch of times. It asks you to type something. It responds to it. So it gives you some very, very basic programming functionality. So now if I want to run this program, or let's say I want to give this program to somebody else to run, what I want to do is come over here to the properties window down here, and you can see the project folder is listed right here. I'm going to go ahead and copy that project folder, and I'm going to open it up in Windows. Here it is. Now you can see those are your program files. Well, now if you want to give the program to somebody else, you have to go in the bin folder. Now you can see by default up here, I have it set as debug. That's just, there's different ways to compile your application. The default is debug. That's my profile I'm using. So I want to look for my program under debug. Well, every time you build your program, it recreates all of these files. The one that you're interested in is this one that says application right here, and it doesn't have VS host on it. So this right here, if I delete everything else, I'll just delete it. Oh, I can't delete it because Visual Studio's using that one currently. But this is your program right there. You could literally give that to somebody, you could send it to them, they could run it, and it would run your code. So now if I open up a console window right here, I can type cd, which means change the current directory, and I can right click and I can paste it. Now I'm going to go into that folder. Now if I type dir, you can see there's my program right there. So I want to run it, so I'm going to right click and say mark just so I don't have to type it in. And I'm going to paste it. Just type the name of my program. Oh, actually, you have to put quotes around it because there's spaces in it. So run the program. There it is. It ran from the command. I type my key. It exits. And you're right back at the command console. Do it again. Hit a key. And you're out. So now you have this program right here. Codegasm, this test app 1 Codegasm exe. That's your program. We just created that. That is the compiled code. So basically, it took our human readable code right here and turned it into machine language that you can then give to somebody else. It's otherwise known as an exe or an application, and then they can run it. Well, guys, there's our first program right there. Well, I hope you enjoyed this first episode of Codegasm. I had a lot of fun. Sorry the video got a little long, but it turns out programming is kind of a hard thing. But regardless, I had a lot of fun doing it, and I'd love to continue doing this series. And you guys get to decide that. Please vote with that like and dislike button. If this video becomes popular and it gets a lot of comments and a lot of views, I'm going to continue to make this series because I really do enjoy programming and I love sharing it with you guys. Again, this wasn't designed to be like a professional tutorial. This isn't a college class. This is about me showing you just very, very simple ways to get up and running with some simple programming methods that hopefully get you interested enough that you want more and you want more and you want more. And you go search those links down in the description. There's lots of good information out there for you guys to continue the education, and keep an eye out for more episodes if you guys enjoyed this. Now, if you made it to the end of this video, I want you to leave a word down in the comment, and that word is going to be Stay Puff. Yeah, the marshmallow guy. By you guys leaving that in the comment, it helps me realize how many people are actually staying engaged throughout the entire video. And it helps me to know if future videos need to be shorter and I need to cut more stuff out. Generally, I don't go this long on a video, but I felt it was necessary to give you the basics on what a function is, how to have a function call another function, and basically how to get input from the user and use that input for something. Those are very, very basic concepts. And there's a lot of stuff I missed in this video, guys. I know this. Literally, programming is infinitely definable. You can do anything. I just wanted to give you guys a little taste so that you could see that it doesn't take hours and weeks and days to write an application. It doesn't. It depends on the application. So guys, I hope you take what I taught you in this small, tiny little lesson and go build on it. And I would love to hear down in the comments what kind of variations you guys do on this. I want to see if you guys take this program to the next level. I would love to see how this influences you. All right, guys, well, I'm going to wrap up this first episode of Codegasm. Had a lot of fun. Hope you did. And until next time. And we got a cover for the piston. And they even give us the tool. Okay, so according to the instructions here, I'm going to save you guys a little time and time-lapse this part.